Okay, folks, what I'm going to do in this video is go through several problems in Unit 7. I'll talk about how I look at the problem, and I'll show you how I work the problem. I hope this helps you. Try to keep in mind that doing problems doesn't mean you know trig. It means you know how to do the problems. But you can learn a lot by watching someone work problems. Here we go. Okay, so this particular problem from 6.1, I believe, was find the equation of the trig function. Okay, first thing I want to do is identify this midline. Okay, the midline. Okay, so remember that's the D, and we want to identify the amplitude. That's the A. It's going up and down 3. Okay. Now this D looks like -4. That's 3. What else we need to do? We need to notice that this is starting off at the 0 mark. This looks like a lot like a sine curve. Okay. So that's one whole cycle. All right. So our mission is to fill in all of the blanks. A. Now, don't blame me for the sloppiness here. I am actually writing a little bit neater, okay, than it may appear. But anyway, it is what it is. Okay, so we found D is -4. We get that. There is no phase shift, so that's 0. A we just found was 3. The only thing we got to do is find B. Now, remember, B 360 or 2 pi over b is equal to the period. Now the period is, I could tell one whole wave takes how long? From here to here, which is 2 units. So 2 pi over b is equal to, can I say it 2 over 1? I would just cross multiply. 2 pi times 1 is 2 pi divided by 2 is pi. B is equal to pi. So to find the answer to that question, I like to use a y. Y is equal to 3 sine of pi x minus 4. Yeah, that's a good little problem to do. All right. Now, this question says find the amplitude, horizontal shift, everything there. Okay, so here you go. First of all, that's the amplitude. Okay, we get that. This is a vertical shift, so it's 7. Y equals 7 would be the midline. Now, the difficulty is understanding what this means. That's B times x minus c. Well, that's actually pretty easy. C is 3, so the horizontal shift is 3 to the right. And the only thing that you need to do is find the period. Okay, remember, I just said the period is 2 pi over b. So the period is equal to 2 pi over 2, which is 2 pi times 2 over pi, which is just 4. So the period is 4. That's how you do that problem. All right, find the formula for the function. Now that is a good question. Well, we have to decide between sine and cosine. This is sine. Sine starts right here. So what I'm going to do is I'm just going to treat it like I'm trying to find the equation of that sinusoid. All right, so remember we have y is equal to a sine of bx minus c plus d. All right, well, number one, I noticed that the amplitude goes up 4, down 4. All right, it's 4. Okay. Now, let's go to the D over here. What is the midline? Well, the midline is what it normally is, which is what x-axis, so that's just 0. Plus 0 just leaves that off. And then we have this b and x minus c. Now notice that it starts at -1, so this is going to be x plus 1. The only thing that we really need to do is figure out what goes in this spot right here. Well, we don't have that location right there, but we know one wave is also the same. It's the same from any two corresponding parts. So between these two, it looks like 10, right? 10? You're right, 10. Okay, so 10 is the length of one wave. Let's do that again. The period is equal to 2 pi over b. The period was 10. Okay, the shortcut is just multiply these guys and divide by that guy. 2 pi over 10. B is equal to 2 pi over 10, or pi over 5. Okay, that's what goes there. It's a little tricky, but that's a good problem. All right, this question, take a look at it. Okay, match each trig function with one of the graphs. Okay, working problems is important. Well, 4 looks pretty easy. Cotangent. Now remember, tangent goes this way and cotangent goes this way. The only cotangent graph is this guy right here, okay? So that would be 4. Secant is 1. Remember, secant is the inverse of cosine. So that would be this guy here, which is 2. Now, cosecant, remember, if you that's a good way to understand how to set that up. So that's 3. And is this tangent? Yes, this is tangent, so that's 1. Not too bad. All right, I'm trying to remember what this is. We could say graph it, but I think what we want to do is we want to find all the information out about it. First of all, it's a cosecant graph. Remember, the cosecant graph looks like this. Okay, but first of all, let's find the amplitude. The amplitude is 4. There's no vertical, so that's 0. And the problem we're going to have is finding the horizontal shift and the period. Let me give you some advice. Factor that 5 pi over 3 out. Okay, you're going to have x minus something. Now let's see, 5 pi times what gives me 20 pi? Well, that's a 4. 3 times what gives me 3? That's just a 1, so there you go right there. So the phase shift, horizontal shift, or phase shift is 4, and then the period is just 2 pi over b. We did this before, so that's just 2 pi times 3 over 5 pi, so that's 6 over 5. Period is 6 over 5. All right, so hopefully that makes sense. All right, look at this. Evaluate the following expressions. What's the inverse sign of radical 2 over 2? Remember, that's a positive value there, so we're only looking in quadrant 1. Sine is radical 2 over 2 at 45 degrees, so you could say 45 or pi over 4. All right, let's look at 5. Inverse cosine of 1/2. Remember, if you watch these other videos that I was talking about, inverse cosine is only defined for quadrant 1 and quadrant 2. Positive values in quadrant 1. What angle is cosine 1/2 at? Right here. Here's a 1/2. 60 degrees. All right, let's do one more. Number 2. Inverse sine of radical 3 over 2. Question, is that a positive value or a negative value? It's positive. We're looking in quadrant 1. If it was negative in quadrant 4. All right, so radical 3 over 2, the sine is radical 3 over 2 at 60 degrees. The unit circle really is key to understanding how to do those types of problems. All right, use your calculator to evaluate each expression. How would I do inverse cosine of negative 0.4? Okay, let's just do degrees for the sake of argument. We got ourselves set in degrees. inverse cosine. Cosine's right here, but you got to do inverse cosine, okay? What was that, negative 0.4? Negative 0.4. 0.4, okay? And should be something in the second quadrant, 113.6 degrees. That would be the way I would work that problem. Okay, you got to try to find this angle. So now, if you notice, you have an opposite side and you have an adjacent side. Opposite and adjacent is sine. Sine of theta is equal to opposite over adjacent. So you remember, you're just going to take your calculator, you're going to do inverse sine, 12 over 19, put it in your calculator. I'm starting to run out of time, so I'm not going to take time to do that. Okay, this is the part that people probably have a lot of questions about. So let me do my best on this. Let me try, okay, to explain this. Evaluate the following expressions. Now remember, this is an angle. So when I compute that, I'm going to get a value. An inverse sine of a value is an angle. My answer is an angle. So let's go inside parentheses first. What is cosine of pi over 4? Cosine of pi over 4 is radical 2 over 2. All right, so what is inverse sine of radical 2 over 2? Where is sine radical 2 over 2? Right here. So the answer is 45 degrees. That's the answer there. Let's try number 21. We'll just do a different color, see if that helps. It's the inverse sine of cosine of 4 pi over 3. First of all, let's find cosine of 4 pi over 3. 4 pi over 3 is right here. Cosine is the x, so negative 1/2. Where is sine negative 1/2? Well, where is arc sine negative 1/2? Remember, the positive values for arc sine are here, the negative values are here. So I'm looking for a negative 1/2. Where over here do I have a y of negative 1/2? Right here. What is that angle measure? 330, but we want it in terms of a negative degree. Okay? Go back and watch my video on the inverse trig functions. All right, number 23. All right, inverse sine of 3 over 7. Well, here's a way we could do this if we're stuck. Okay, here's my angle, and here's a right triangle. Sine is opposite over hypotenuse. What is the cosine of that angle? That's a good question. 49 minus what? 9? So that's going to be 40, square root of 40. So what is cosine? Cosine is going to be radical 40 over 7. Radical 40 is 2 radical 10. 2 radical 10 over 7. Now, folks, you could actually plug that in your calculator and get the equivalent there, so keep that in mind. I don't suggest that shortcut, but I do want to let you know that's available. All right, last question. How am I going to do this problem? All right, this looks so complicated, but let me just explain it. This is not an exact value, but it's in the position of a value, isn't it? Okay, so just draw a general triangle. Now we've got to find theta. I'm going to just stake my claim here. Here's theta. And cosine of theta is x over 2. Cosine's adjacent over hypotenuse. If we did the Pythagorean theorem, wouldn't this be 4 minus x squared? Or radical? Now the question is, what is tangent? What is tangent of this angle theta? Tangent is opposite over adjacent, radical 4 minus x squared over x. Now, I tried to take some sample problems, and if it went too fast for you, it means the basic concepts are really not ingrained yet. Take a little time. Do the best that you can. That's all you can do. But keep at it, and hopefully you'll experience success. Thank you.